So with this, we are done with mean, and we now move on to the mode of grouped data. But to understand mode, we will look into its definitions first. So mode is that value among the observations which occurs most often. So it is the value of observation which has the maximum frequency. So I hope you remember what a frequency distribution table looked like. So this xi, fi, a table having these columns is called a frequency distribution table. So you should know what this table refers to. It's the frequency distribution table. So here you look at the frequencies. So spot the observation which is having the maximum frequency, and that is how you will get your mode. So it can be there that more than one value has the same maximum frequency. So for example, I can give you some data like xi, fi. Let me give you the observations 2, 3, 5, 7 having frequencies 4, 1, 4, 2 respectively. So in this data, tell me what is the maximum frequency? Well, that is 4. But is this 4 having its occurrence for only one observation? No, it's occurring twice. Once for the observation 2 and next time for the observation 5. So this is called multimodal then. So this data is said to be multimodal because more than one value, okay, 2 and 5 respectively in this case, are having the same maximum frequency 4. Well, the good part is that we won't be dealing with multimodal data in this chapter. We'll be just limited to data which will be having just one mode. So now we know that data can be of two types. So quickly tell me what are the two types of data that we discussed. So the data could be ungrouped or it could be grouped. How do you identify, by the way? So grouped data will have class intervals, ungrouped data won't have class intervals. They'll straight away begin with xi, fi values. Alright, so now how do you calculate the mode for ungrouped data? What you are going to do is you will make a frequency distribution table first of all. Okay, you know by now what a frequency distribution table looks like. So in case of ungrouped data where there are no class intervals, the table will look like xi and then you'll have a column for fi. So here the data has been given to you in the raw form. Let's convert it into a frequency distribution table. These are my observations xi. So they are basically my number of wickets if we go by the question. And then we have fi, which are the number of matches. Okay, so now which is the smallest observation here? That is 0. So let's write that 0 first. Then we have 1, 2, 3, 4, 5, 6. So 0, 1, 2, 3, 4, 5, 6. Now how many times is 0 occurring? It's occurring only once. So corresponding frequency would be 1. 1 is occurring how many times? Only once. 2 is occurring how many times? 3 times. What about 3? 3 is occurring twice. 4 is occurring once. 5 is occurring once. 6 is occurring once. So this is the frequency distribution table that we obtain in this case. Okay. So now identify the maximum frequency. So to identify this maximum frequency, you need to refer to this column. And here obviously 3 is the maximum frequency. So your answer is 3. So what will be the mode of this data? The mode will be 3. Okay. So corresponding to this, the value is 2. Is it clear? So this is how you go about calculating mode for ungrouped data. But we prefer using grouped data for all the right reasons. And in that case, we make use of formula. Okay. So if you've been given data, it could be ungrouped. So then you just spot the maximum frequency. And if you've been given grouped data, then it's difficult to spot the maximum frequency. What you'll do then is you'll make use of this formula. So this formula is L plus F1 minus F0 upon 2 F1 minus F0 minus F2 into H. Now out of all these terms, tell me how many terms do you know? Well, I expect you to know at least one term, and that is H over here. What was H? It was the class size. But which class size are we referring to? So to understand that, we need to understand this concept, modal class. So grouped data is collected in the form of class intervals. So it will be like 1 to 10, 10 to 20, etc. So now then you will have say 20 to 30, and let's say I give you some frequencies over here, 3, 5 and 7, or let me make it 3, 7 and 5. Okay, so you've been given these class intervals and you've been given these frequencies. Now spot the maximum frequency, that is 7. Okay. Now corresponding to this maximum frequency, whichever class interval you are having, this class interval is called the modal class. Okay. So it is the class where the mode is potentially present. Okay, that is the class with maximum frequency where mode is likely to be present. So that class is called the modal class. So this modal class's class size we measure 20 minus 10, so that will become h in this case. Okay, and what about L? L is the lower limit of this class, so in this case it will be 10. What is F1? F1 is the frequency of that modal class, that will be 7. F0, so it's 1 minus, right? So F0 will be frequency of the previous class, okay, preceding the modal class, so that will be 3. Then F2 is greater than F1, so not in the literal sense, but because 1 is greater than 2, so F1 and F2. So you look at the succeeding class, that is 20 to 30. Its frequency is F2, so that will be 5. So let me just show you what this means. So in this table, we've identified the modal classes 10 to 20 because here our maximum frequency 7 is lying. So now H we know will be 20 minus 10, in this case that is 10. What will be L? L will be the lower limit, that is 10. What will be the F1? Frequency of modal class 7. F0 is frequency of preceding class, that will be 3. F2 is frequency of the succeeding class, and that is 5. So just substitute them in this formula, you will get the mode for the given data. So how will you get it? Mode is equal to L, that is 10, plus F1 minus F0 will be 7 minus 3. Upon 2 F1 will be 2 into 7, 14, minus F0 will be minus 3, minus F2 will be minus 5, multiplied by the class size 10. So this will be 10 plus 7 minus 3 will be 4, 14 minus 8 will be 6 into 10. So if you solve for this, you will get 10 plus 20 upon 3, and that will be 50 upon 3. So that will be the mode of the given grouped data. So that's how you go about it. So we have more examples on this. So here we've been given family size. It is in the form of class intervals, which means this is grouped data. Then we've been given the number of families, which means frequencies are given to us. So the total, the sum of frequencies will turn out to be 20 because they've said that there are 20 households. Okay, so for this given data, you need to find out the mode. So to find out the mode, you need to identify the modal class first of all. So so what is the maximum frequency in this case? Look at the Fi column and tell me what's the maximum frequency. Well, that is 8. So what will be the modal class? That is the class having this maximum frequency. That is this 3 to 5. This is the modal class. Okay. Now what was the formula for mode? That was L plus F1 minus F0 upon 2F1 minus F0 minus F2 into H. So this is the modal class. What is the lower limit of this modal class 3 to 5? L is equal to 3. What is H? 5 minus 3 it is 2. What is F1? Frequency of this class is 8. What is F0? Frequency of the preceding class is 7. What is F2? Frequency of the succeeding class, that is 2. Substitute all of them. So it will be 3 plus 8 minus 7 upon 2F1 will be 16. Then minus 7 minus 2 into H is 3. So this will be 3 plus 1 upon 16 minus 9, which will be 7 into 3. So it will become 3 plus, here the H will be 2, 5 minus 3, so it will be 3 plus 2 upon 7, and that will become 23 upon 7, and if you convert it into decimals, your answer will be 3.286. The mode of this data is 3.286. Then we have another example. So look at the data and tell me if it is grouped or ungrouped. It is grouped. So you've been given the class intervals and you've been given number of students, which means this is Xi or Fi. This is Fi. Okay, this is the frequency table, the column. So what you need to do is you need to find out the mode of this data, and this is the same example where we were talking about some students, and these were the marks of students which were given to us, and we discussed this by ungrouped data also, group data also. We found out its mean also. So we need to just need to find out the mode in this case. So to find out the mode, you need to identify the maximum frequency. So what is the maximum frequency here? That is 7. What is the modal class in that case, which is having this frequency? that is 40 to 55. Alright. So now can you quickly tell me what is h here? It will be 55 minus 40, that is 15. What is your frequency of this class? That is 7. What is the lower limit of this class? That is 40. What is the frequency of the preceding class? That is 3. What is the frequency of the succeeding class? That is 6. So what was the formula for mode? It was L plus F1 minus F0 upon 2 F1 minus F0 minus F2 into H. Quickly plug in the values. So L is 40. F1 minus F0 will be what? 7 minus 3, that is 4. 2F1 will be 2 into 7, 14. Minus 3 minus 6 into H is 15. So this will become equal to 40 plus 4 upon 14 minus 9 will be what? It will be 5 into 15. So 5 3s are, you will have 40 plus 12. That will give you 52. So the mode of this data is 52. So if you remember, for the same grouped data, when we calculated the mean, just flip back your pages, you will find this question. So the mean turned out to be 62 and now the mode for this data is turning out to be 52. I'm telling you again, they are just numbers for a layman, but for a mathematician, they are more than numbers. So just tell me, how can you interpret this? So we said that mean meant that the average marks for this class turned out to be 62. Mode means maximum frequency. So this means that the maximum number of students in this class scored what marks? They scored 50 marks. Okay. So maximum students scored 50 marks and the average marks of the class were 62. So now here your mode in this case turned out to be lesser than your mean, but it's not necessary. So mode can be greater than mean, mode can be equal to mean, mode can be less than mean. It just depends on your question. If you've understood mode and mean, we now move on to median of grouped data. So what is median? So median is a measure of central tendency. Now in fact, if we talk about measure of central tendency, there are 3 measures of central tendency, 2 of which you've already done and you don't even know it. Don't even know that. So it's mean, mode, and now the third one is median. But what does central tendency mean? First of all, measure is clear that we are measuring something, but what are we exactly measuring? What is the central tendency? So central tendency means the central value for a distribution. So we've seen frequency distribution so far. So the central value for a distribution, okay, the way you've distributed your data according to frequencies or whichever parameter, the central value for that is your central tendency. Okay, so by measure of central tendency, we mean that we are measuring a single value which will describe your data set, okay, by identifying the central position within that set. So mean, mode, they're all attempting to basically provide a description for your set of data, okay, that you're having. To make sense of that data, whatever measures we are calculating, they are called measures of central tendency. They are all hinting at central value for the distribution that you're dealing with. Okay, so we've discussed mean and mode. We now move on to median. So what is median? This is the middlemost observation in the data. Okay, but it's not always easy to spot. Alright, so if I give you 1, 3, 5, 7, 10. So here what will be the middlemost value? This will be 5. But if in the same data I add one more number, say 11, now you're having 2 numbers in the middle, 5 or 7. So which one will you choose? So that makes it confusing. So in this case, you will take the 2 values in between in the middle, that is 5 plus 7, and you will take their average. So 5 plus 7 upon 2, and that will be 12 upon 2, that is 6. But that is what we are doing like by mental math. But there's a specific formula for that. Let's just see that. So far we've seen that your data can be of 2 types. It could be grouped or it could be ungrouped. So first let's see how to calculate the median for ungrouped data. So your data, if it is ungrouped, so first of all you need to arrange your data in ascending order. Okay, arrange your data in ascending order and then calculate the number of observations that you're having. Okay, you have to calculate n. So if this n is odd, then your n plus 1 upon 2th observation will be your median. Okay, n plus 1 by 2 will not be the median, but n plus 1 by 2th observation would be the median. So be very careful. And then if n is even, then you take the average of the two middle terms, which will be n by 2th and n by 2 plus 1th observation. Again, I said that they are observation numbers and not the observation themselves. So you have to take the average. Okay, and if it is grouped data, like we had a formula for mode, we have a formula for median also. So here you need to directly use the formula. Okay, so if your data is ungrouped, what you will do, you will first of all arrange your data in ascending order. You will calculate the number of observations n. If this n is even, what will you do? You will take the average of the two middle terms, n by 2th and n by 2 plus 1th. If it is odd, then it's very simple. You just need to look at the n plus 1 by 2th observation. And if it is grouped, then you just need to make use of your formula. So if I give you 1, 3, 5, 7, 9, this is your data. But let's say I shuffle it up. Okay, I give you 3, 1, 7, 5, 9. So you can't attempt to find median by this method. It will give you the value 7. So that will be wrong. So the first step is very important. You have to first of all arrange your data in ascending order. So it will become 1, 3, 7, 5, 9. Now I understand that just by looking at the data, you can make out that the middle term is 5. But if we go by the mathematical procedure for the same, we will first of all arrange it in ascending order. So the first step is done. The second step is to calculate n, the number of observations. That's 1, 2, 3, 4 and 5. So n is equal to 5. What is 5? It is even or odd? It is odd. So then what was the formula to calculate median? It was n plus 1 upon 2th observation. So instead of n, we can now put 5. So it will be 5 plus 1 whole upon 2, that is 6 upon 2, that is third observation. So it's not the number 3, but the observation number 3. So that is 5. So in this case, the median turns out to be 5. Now here itself, if I add one more number, say 10, then you're having these two observations in the middle. So what do you do now? You calculate n. This is already in ascending order. So n is 6 here, which is even. So now median will require average of two terms. Your n by 2th observation and n by 2 plus 1th observation. So what will be your n by 2th observation? That is 6 by 2, that is third observation. And 3 plus 1, that is 4th observation. So 4th observation. So how do you calculate the average? You simply take third observation, which is 5, the fourth observation as 7, and you divide it by 2. So 7 plus 5 by 2 will become 12 by 2, that is 6. So if it is even, what you realize is that you're getting an observation which is not even present in your data. So this is how you go about calculating median for ungrouped data. So what is this data? Is it ungrouped or is it grouped? Well, that is ungrouped because here no class intervals are given to you. So you've been provided with the marks obtained, so that will be your xi, and number of students means this will be fi. So you have to find out the median of this data, and here we've been given marks out of 50 and total number of students is 100. So first of all, just check if it's in ascending order. So the data is not in ascending order. So first we'll arrange it in ascending order. So that will become 20. Then you can take up to 25, up to 28, 29, 33, 38, 42 and 43. So first of all, you arrange it in ascending order. So you take 20, 25, 28, 29, 33, 38, 42 and 43. Now what you need to do is you need to write down the number of students. So here 20 marks were scored by how many students? By 6 students. Now here I have said up to 25. So up to 25 means students who scored 20 marks plus students who scored up to 25 marks. So we'll add both of them. So there were 6 students who scored 20 marks plus how many students scored 25 marks? 20. So here the answer will not be 20 but 20 plus the previous frequency, that is 6. So 20 plus 6, 26. Up to 28 means what? Up to 25, how many students got these up to 25 marks? 26. And then how many students got 28 marks? 24. Up to means less than equal to. So if I give you up to 29, so how many students got up to 28 marks? 20. This was 40. This was 50. So this will become 50 plus 29 marks have been scored by 28 students. So 50 plus 28 will become 78. Then up to 33 means take the students who scored up to 29, that is 78. Plus how many got 33 marks? 15. So 78 plus 15 will be 93. So in a similar manner, you take 93 plus 38 marks were scored by 4 people. So this will become 97. Then up to 42 means you will take 97 plus 42 was scored by 2. So it will become 99. Then you will have 99 plus how many students got 43? 1. So you get 100. Okay. So this is a little different. So when we are calculating median, we will usually make use of another term which is cumulative frequency. And in fact, this table over here for xi and this cumulative frequency is written as CF. Okay. So this is actually cumulative frequency and this is your frequency. So this can be said to be a frequency distribution table. But this is something new. Here you are not having frequencies but cumulative frequencies, and this table will hence be called cumulative frequency table. Now you must be wondering, what does this term cumulative frequency mean? So it is used to determine the number of observations that lie above or below a particular value in the given data. Okay, so how is it different from your frequency? Both are telling you the numbers of students only in this case. So how is cumulative frequency different from frequency? So frequency just deals with the present frequency, but cumulative frequency takes into account the previous frequencies and then adds them to the present frequency. So here 20 students, so here 6 students got 20 marks. So 6 students got 20 marks. But if we talk about up to 25, so we will take the previous frequency 6 and then add the present frequency 20 to get 26. Then up to 28. So you will take the previous frequency which is 26, add the present frequency 24. So this is the difference between the two frequencies. Okay. So this is your xi, this is your fi, and this is your cumulative frequency. Okay. So whenever you are dealing with median, you will have to calculate this. It's nothing but you will take 6, then 6 plus 20. Then you've taken 26. So 26 plus 24. Okay, then you've taken 26 plus 24, that is 50. Then you will take 50 plus 28. 78 plus 15. Then 93 plus 4 will give you 97. 97 plus 2 will give you 99. 99 plus 1 will give you 100. Okay, so in like a zigzag fashion, that's how you get these cumulative frequencies. But the question still remains, how do you calculate the median for this data? So, so here, whatever term you are having in the end for this cumulative frequency, that is your n in this case. Okay, so you know, for ungrouped data, you need to arrange it in ascending order, which we have already done. Then you can calculate the cumulative frequency as well. In this case, you will get this n. So this is your n. Now you will figure out if it's even or odd. So 100 we know is even. So you look at two observations. What are those two observations? N by 2th and n by 2 plus 1th observation. So that means 50th and 51st observation. So when you're looking for these observations, you look at the cumulative frequency table. So 50th observation will lie over here. So that will be 20th. Observation means you will refer to xi. So for 50th observation, you will have this value 28. Okay. Then you will have 51st observation. So then you will look at this 78th one and here you will get 29. Then you have to take the average. So 28 plus 29 upon 2. And this will give you the median as 28.5 for the given data. Okay. So it could be too much to assimilate in one go. We'll practice this with more examples as well. Just keep in mind, get xi, fi, calculate these cumulative frequencies. Look at the last value, that is your n. Figure out if it's even or odd. Accordingly, make use of the formula. And then detecting the correct observation is also a task, let me tell you. So if it's 50, you look at this. If it's 51st, it will be somewhere in that 78 window, right? 50 to 78 window. So we look at this 29 for the 51st observation. It will become clearer with further examples. So here again, we have cumulative frequency table provided to us. So here the class intervals are given to us, which means for a change, we are now having grouped data. Grouped data. So these are your class intervals. Number of students means these are your frequencies. So here the total number of students are 53 and you've been given marks out of 100 in a certain examination. So how do you go about solving the median for this? So you will first of all make a cumulative frequency table. That means you will need to have your xi value, you will need to have your cumulative frequency column. Okay. So how will you get xi? Here the xi's are not directly provided to you because this is grouped data. So here you will calculate these xi values by using the formula of class mark. So here you need to calculate the cumulative frequencies And let's see how we do that. So cumulative frequency table can actually be of two types. It could be of less than type or it could be of more than type also. But we will first look at this less than type and then we'll move on to the more than type. So marks obtained less than 10. How many students got marks less than 10? That will be 0 to 10, that is 5. So here we are not writing frequencies anymore. What we are writing is cumulative frequency. Less than 20 means the previous frequency 5 plus how many students got 20 marks, or less than 20 marks, that will be 3. So 5 plus 3 total will become 8. Then you will take 8 plus 4, that is 12. Then you will take 12 plus 3, that is 15. 15 plus 3 is 18. 18 plus 4 is 22. 22 plus 7 is 29. 29 plus 9 will be 38. 38 plus 7 will be 45. And 45 plus 8 ultimately will become 53. Alright. So once you've written these cumulative frequencies, you need to look at the last value. This is how you make a table for cumulative frequency of the less than type. Now we have a look at the cumulative frequency of more than type. So here we've been given marks and frequency. So more than type will have, instead of less than, we will have more than or equal to. So if they say more than or equal to 0, then you will sum up all these frequencies in this more than type. So the first one will be sum of all the frequencies. So if you sum them all up, you will get 53. Then if you do more than or equal to 10, so you will do 53 minus this times 5. So notice the change in writing the cumulative frequencies. Okay, so there's a difference between writing the cumulative frequencies for less than type and writing the same for more than type. However, whichever method you choose, you will get the median as the same. So 53 minus 5 in this case will become 48. Then you will take 48 minus 3. That will become 45. Then you will do 45 minus 4. That will become 41. 41 minus 3 will be 38. 38 minus 3 will be 35. Then you will do 35 minus 4. That will become 31. Then you will get 24, 15 and ultimately you will get 8. So note the difference between the two tables. So then we see how we calculate the median of grouped data. So clearly by now you must have understood that we need to make a cumulative frequency table. But we saw the two types of table also that we get, less than type, more than type. But I never told you how to calculate the median by making use of those tables. So we'll just learn that now. So in a group frequency distribution, whatever you're getting as the end value for cumulative frequency is what is your n. Okay. So whatever you were having as the last cumulative frequency, that becomes your n. What you need to do is, first of all, you need to find this n, the number to divide this n by 2. Okay. Then what you need to do is you need to locate the class with cumulative frequency greater than n by 2, or basically near about n by 2, and that class is called the median class. So like in mode, where the class which could potentially have your mode was called the modal class, your median class is that class which could potentially have your middlemost observation or your median. So to find this median class, you need to do a little bit of work, which is first of all make a cumulative frequency column. Okay, then look at the last value for cumulative frequency n, do n by 2 and then locate the class which is having cumulative frequency close to this. So this is the formula that I was talking about. So median is equal to L plus n by 2 minus Cf upon F into H. So here if you've spotted your median class, okay, let's say it's 10 to 20, so you will take the lower limit, that is L. Then you will take H, which is the class size. So upper limit minus lower limit, like in this case 20 minus 10 is 10. Then n by 2, I told you n is that last number which we are getting for cumulative frequency divided by 2. Then what is this cumulative frequency? This is not the cumulative frequency of your median class, but of the preceding class. Okay. And what is this frequency? Frequency is of the median class only. So just understand these parameters and then we'll employ them to solve for the median of grouped data. So if you remember the previous example where we wrote the cumulative frequency table for more than type and less than type, you must have seen that for less than type, the last term was n equal to 53. So we'll call that n because that was the last value. So we write n. So I'm telling you the step for group data. So number 2, the step was to calculate n by 2. So that will become 53 by 2, that is 26.5. So now if you look back, this 26.5 lies closest to 22 and 29. But which one do you choose? You choose the one which is greater. So that is the deciding factor. So 26.5 is close to both 22 and 29, but we choose the greater number, that is 29. So then less than 80 means 70 to 80 becomes your median class in this particular example. So if you've understood how to find median, so if you've understood how to find out the median class, then you need to find these parameters as well, substitute them in the formula and get the median. So here we have an example, the same marks example. So here this is group data, we've been given class intervals, we've been given the frequencies, and we have calculated these cumulative frequencies. So it was 5, then 5 plus 3, 8. Then 8 plus 4 gave us 12. Then 3 plus 12 gave us 15. Then 3 plus 15 gave us 18, 4 plus 18, 22, and so on and so forth. Now, if you notice here, we've not been dealing with xi values so far. So here to calculate median, you don't really require xi. So you look at the last value, which is 53, so n is equal to 53. So we've obtained n. Then what is the second step that you do? N by 2. So 53 by 2, that is what? 26.5. So you have 26.5. So if you look carefully, your 26.5 will lie in this class, 60 to 70. Okay, so it's closer to 22 also. It's close to 29 as well. But which one do you choose? You choose that cumulative frequency which is greater. So 29 is greater than 22. So we choose this 60 to 70 as a median class. So it's very simple if you've identified the median class once. That is 60 to 70. Now quickly tell me what is the lower limit of this median class? That is 60. What is the class size? 70 minus 60, that is 10. What is the frequency of this median class? That is 7. And what is the cumulative frequency of the preceding class? That is 22. And n by 2 we've already calculated as 26.5. Now just write the formula for median, which was equal to L plus n by 2 minus cumulative frequency upon frequency into your class size. So L here is 60, n by 2 is 26.5, cumulative frequency is 22, the frequency over here is 7, and class size is 10. So when you solve for this, you will ultimately get 60 plus 45 upon 7. So the answer in decimals will be 66.4. So again, I don't want my students to just work with numbers, but to also understand each and every step. Okay, so 66.4 is the median marks that we're getting. So what does this mean? That half of the class got marks greater than 66.4, and the remaining class got marks less than 66.4. Okay, so if you remember, for the same class we've calculated the mean as well, 62, and the mode as well, which was 52. So now we can basically comment on three things for the class. That what are the average marks of the class? 62. What is the maximum marks that the class has got? So maximum students got what marks? They got 52 marks. And then 50% of students got marks above 66.4, and the remaining got marks less than 66.4. So then we have another example. So now here we've been given the heights, we've been given the number of girls, so we've been given the cumulative frequencies over here, but we have no idea about the frequencies. But it's no big deal. So far we knew frequencies and we were calculating cumulative frequencies by adding the previous frequency to the present frequency. So now we can move backwards and use the cumulative frequencies, subtract them and get the frequency. So the first frequency will be 4. Now the second one, instead of adding them, we will get it as 11 minus 4, that is 7. Then we can do 29, the present cumulative frequency minus the previous one, so it will be 29 minus 7. So this will become 29 minus 11, then this will become 40 minus 29, 46 minus 40, 51 minus 46. So this will be 5, 4, 29 minus 11 will be 18, and 40 minus 29 will become 11. So these are the frequencies that we've obtained. These were the class intervals basically. So now we are writing the class intervals, okay, by converting those languages and words to these class intervals. So below 140 the frequency was 4, and what was the cumulative frequency? Just refer to that example and just copy them. The cumulative frequencies were 4, 11, 29, 40, 46 and 51. So now look at the last cumulative frequency, that is your n. So here n is equal to 51. But what is of interest to us? N by 2. That will be 51 by 2. That will be 25.5. Now look, where will we have 25.5? So here there is no point of confusion. It will definitely lie over here. So what will be the median class? Please answer. The median class will become 145 to 150. So tell me the lower limit of this class. That will be 145. What will be the age here? The class size 150 minus 145, that is 5. What is the frequency of this class? That is 18. So here we can't just do without frequency. We need to calculate this frequency column as well. So f is equal to 18, then cumulative frequency will be that of the preceding class, that will be 11. So now what was the formula for median? It was equal to L plus n by 2 minus Cf upon f into h. So let's just plug in the values. So it will become 145 plus n by 2 we've already found as 25.5 minus the cumulative frequency 11 and frequency is 18. The class size is 5. So when you solve for this, you will get 145 plus 72.5 upon 18, and ultimately you get the answer as 149.03, but it has a unit centimeters. So we can say that the median height of girls is 149.03 centimeters, which means half of the girls are taller than this and the other half are shorter than this. Then we have another example on median of group data. So you've already been given the median. So this is a twisted question, but very interesting, let me tell you. So you've been given the class intervals, you've been given the frequencies. So you should already get this hint that you need to calculate the cumulative frequencies. Okay, so here the total frequency is 100. That is already given to us. That means the last cumulative frequency that you'll get, n that we are saying, that will be equal to 100, and the median is given to you as 525. So if median is already given, what are we finding? We're finding this x and y. What are these x and y's? They are the frequencies here. So for that you need to first of all form a cumulative frequency table. So you will take 2, then you will do 2 plus 5, that will give you 7. Then you will do x plus 7 plus x, that will be 7 plus x only. Then you will add 12 to this, so this will become 19 plus x. Add 17 to this, so that will become 36 plus x. Then you will add 20 to this, that will become 56 plus x. Then you will have 56 plus x plus y. Then you will have 65 plus x plus y, 72 plus x plus y, and ultimately we get 76 plus x plus y. So these are the cumulative frequencies that we get. So let me quickly write down these cumulative frequencies here as well. So these were the cumulative frequencies that we just calculated. After filling them in this table, you can say this is your CI, this is your FI, this is your cumulative frequency. Now this last cumulative frequency is what we are calling N. So here N is equal to 76 plus X plus Y. But according to the question, that means ATQ, short form for according to the question, we've been given that N is equal to 100, right? So we can equate the two. So we can say 76 plus X plus Y is equal to 100. So x plus 5 will become 100 minus 76, that is 24. So make this equation number 1. But we were also given one more thing, which was median. The median was given to us as 525. Now how can we find median using this? So if we know n, we can find out n by 2. So 100 by 2 will be 50. So where will we have the cumulative frequency 50? Again, there should be no confusion. It will lie over here in 56 plus x. So your corresponding class is 500 to 600. So the median class will be what? So like normally you calculate cumulative frequency for group data. In a similar manner, you just need to proceed, except here we are just having some variables. So that shouldn't confuse you. So median class is 500 to 600. What do we do next? We look at the lower limit, that is 500. We look at the frequency of this class, which is 20. We find out the class size, which will be 600 minus 500, that is 100. We look at the cumulative frequency of the preceding class, that will be 36 plus x. Then what do we do? Nothing. We just make use of the formula, that median is equal to L plus n by 2 minus Cf upon f into h. Let's quickly substitute over here. So L is over here 500, n by 2 we've found as 50, minus cumulative frequency is 36 plus x, so this will become 36 minus x, upon f is 20 and h is 100. So this will become 25, then you will have, so median is already given to us, but that is 525. So we can say 525 is equal to 500 plus 5 times 50 minus 36, which is 14 minus x. So I can then say 525 minus 500 is equal to 5 into 14 minus x. So let's clear up some space. So this is nothing but your simple linear equation in terms of one variable, that is x. So you will get 25 is equal to 5 into 14 minus x. So this goes like this. So you will get 5 is equal to 14 minus x. Let me take this x on the LHS, so it becomes plus x. You'll have 14 minus 5 here, 9. So we get x equal to 9. Now you remember we took equation number 1, so substitute this value of x in that first equation. That equation was x plus y is equal to 24. So now it will become 9 plus y is equal to 24. Y will become equal to 24 minus 9, that is 15. So with this, we are done with this question. X is 9 and y is 15.